All right, so we talked about parallel lines last time. Now we're going to work on proving lines are parallel. So we learned about that transversal line and what it did when we had parallel lines, the different angle pairs. So we'll use those angle pairs and use the converse of those statements to prove lines parallel. So let's get with it. So corresponding angles converse. If two lines are cut by a transversal, and the corresponding angles are congruent, what do we know about the lines? Well, we knew what was true. Well, if we had lines parallel, corresponding angles had to be congruent. So if the angles are congruent, we know the lines have to be parallel. So let's apply that now. Find the value of x that makes line M parallel to line N. Well, if they're going to be parallel, these angles have to be the same. So 65 needs to be the angle measurement up here. So we'll make an equation, 3x plus 5 equals 65, and we'll solve for x. So subtract from 5 on both sides, 3x is 60, and divide by 3, x is 20. So if x is 20, both angles are 65 degrees. Okay, so you can probably guess that the alternate interior angles, alternate exterior angles, and consecutive interior angles converse statements. So we know if lines are parallel, alternate interior angles are congruent. So if we know alternate interior angles are congruent, we know the lines are parallel. And alternate exterior angles. Well, if we know lines are parallel, these angles are congruent. So if the angles are congruent, lines have to be parallel. And then consecutive interior angles converse. Well, when we knew lines were parallel, these two angles were supplementary. So if the two lines are cut by a transversal and consecutive interior angles are supplementary, well, then we know the lines have to be parallel. Okay, so we know that those statements have to be true. Now let's take a look. Why don't you pause the video and see if you can prove if lines A and B are parallel. Be ready to explain why or why not. So lines A and B in this one. What did you say for that? Are they parallel? Well, if you said so, you were correct. How do we know? Well, if these two angles are congruent, according to the diagram, and they are alternate exterior angles, we could say, well, by the alternate exterior angle converse, well, they would have to be congruent or parallel, rather. What 4 and 5? We know these two angles were congruent, and we know those angles are corresponding. So by the corresponding angle converse, just abbreviating here, we would say yes, they are. So corresponding angles are congruent, lines are parallel. How about number 5? Measure of 1 plus measure of 2 equal 180. Well, I can think of one example where it would work. Well, if this is 90 and this is 90, well, all the angles are 90 and the lines are parallel. Can you think of a counterexample? Let's see. So if I get my eraser, we know that well, if this were 80, this would have to be 100. These are 80, and these would have to be 100. And it doesn't appear that it's going to match up very well. So those lines would not be parallel. So I found my counterexample. How can I prove it never works? Well, these two angles are alternate exterior, or rather alternate interior angles. When those are congruent, we have parallel lines. But the ones that are supplementary would be the alternate or same side interior. So we would say that that's not parallel lines. Okay, so let's prove the alternate interior angles converse. So if two lines are cut by a transversal, so alternate interior angles are congruent, that'd be angles 4 and angle 5. How do we know the lines have to be parallel? Let's take what we know first. 4 is congruent to 5. And if we're looking at angle 1, that's the next angle we can determine, because we know 4 and 1 have to be congruent. 4 and 1 have to be congruent because they're vertical angles. Vertical angles are congruent. So next now relate 1 and 5. 1 and 5 have to be congruent because now the transitive property. 4 is congruent to 5. 1 is congruent to 4. So therefore, 1 is congruent to 5 as well. So if 1 is congruent to 5, we know by corresponding angles converse that two lines have to be parallel. Let's take a look at how we can write and form a paragraph proof. We talked about that in our first lesson in this unit. This kind of helps us to lay the framework for it and kind of how we can organize that. So if we have A parallel to B, oops, it's not drawn very well. So I'm just going to draw my diagram. What I know, A is parallel to B. 1 is congruent to 3. How do I prove? So maybe I'll put that in a different color. How do I prove that X is parallel to Y? So I want to be able to prove that. Well, look at your diagram to make a plan. A diagram has angles 1, 2, and 3 drawn in there. And probably suggesting that we should use those angles. So let's focus on one transversal at a time. So first of all, 1 and 2. Well, I'm not going to prove that lines X and Y are parallel with those, but what do I know about 1 and 2? Well, since lines A and B are parallel, 1 and 2 are corresponding angles. So 1 and 2 need to be congruent. So if I look at those two angles, I can mark those two are congruent. Because A is parallel to B and they're corresponding angles. Now if I look at 2 and 3, I've already marked 2 as the same as 1, and 1 was the same as 3, so 2 has to be congruent to 3, as you can see by the markings in my diagram, and it's because of the transverse or transitive property. So if 2 is congruent to 3, these two are alternate exterior, and if alternate exterior are congruent, the two lines have to be parallel. So I can prove now that line X is parallel to line Y. So through that transitive property, I can mark down kind of things that I want to say. Transitive property, I know that 2 is congruent to 3. And by the alternate exterior angle converse, I can say that the lines are parallel. So if I can kind of just throw everything down that I want to say, then throw it into a paragraph. So it's given that A is parallel to B, so we said by the corresponding angles theorem, 1 is congruent to 2, and as we're writing that paragraph, we're just kind of listing all our steps that we said. We also said it's given that 1 is congruent to 3, so we said, well, we can now say that 2 is congruent to 3. Angles are congruent by the transitive property of congruence. It applies for angles as well. Therefore, by the, well, what did we list out here? The alternate exterior angle converse. I'll just abbreviate again, exterior angle converse. We can say that line X is parallel to line Y. So kind of just throwing what you know on the diagram and then throwing things down out here that make sense to you, then we just form a paragraph of things that we know. And it doesn't have to be in these words, but you want to write down what you know and how you know it. It's given to me. I know A is parallel to B. And by corresponding angles theorem, I know 1 is congruent to 2. So it's kind of like writing the two-step proof, except it's not so confined in the orderly steps. You can write down many words or kind of as little words, but you just still have to list statements and reasons. Final thing we want to take a look at is the transitive property of parallel lines. So we've applied that transitive property before. So the same with parallel lines. If two lines are parallel to the same line, so for instance, P is parallel to Q. Q is parallel to R. Well, if P is parallel to Q and Q is parallel to R, P has to be parallel to R. So they're all parallel to each other. And you can kind of see how that makes sense as we take a look at this example. All these steps. Each step is parallel to the step above it. So as you're walking down the steps, if each one is parallel to the one above it, they're all parallel to each other. If the bottom step's parallel to the ground, this top step has to be parallel to the ground. So he's a good builder. He built all the steps parallel to each other. And if he built his first one parallel to the ground, he didn't have to build the top one parallel to the ground. You just build it parallel to the one above it. They'll all be parallel. So just taking what we learned last time about parallel lines and transversals and applying those converse statements to help us form equations and write proofs. Any questions? I can help you out with that in class.